No, thank you very much for having me. As I was saying, this is the first time I've given this presentation, and I'm really excited to not just give it because I know what I'm going to say, but also this is like, I see this as much for you guys to direct conversation and ask questions, whatever you want to get into. So like as we go, please ask questions. I'd love this to be a discussion. There's just 7 of us here. So that's a nice number. I think we can have a really good chat about some things. So please ask questions. I'll show you what I've got, and hopefully we'll have some, I'm sure we'll have time at the end for questions. And yeah, and if you want to just sit back and listen for now, that's great. But if you have something you definitely, does anyone have something they definitely want to chat about tonight? Like, I don't mind writing it up and seeing if I can loop it in. Like, or people just, okay, sitting back for a second and, okay. Okay. So I'm going to start tonight with 2 stories that kind of help, I think, bring me here with you tonight. We'll talk a little bit about software development and testing and roles and working on teams and things like that, a little bit on programming, and then we'll hopefully bring it all together and I'll share some ideas and why I think this is such an interesting topic for people. So story number 1. A long time ago, I was working on a big energy trading project for British Petroleum. And what was really neat about this project was we had an incredible automated testing framework that we built ourselves. So this was an energy trading platform. BP basically wanted to know what their traders were doing to make them all this money. The traders, ironically, didn't want BP to know what they were doing, but it was kind of like an auditing type thing. They want to know, like when you make a deal and you're shipping oil from Chicago to Singapore, what boat is it on? How are you setting the price? All this kind of stuff. So anyways, it was like a Java Swing client. It was that long ago. So it was a thick client, Java, and we wrote our own automated testing framework so that when you fired up the trading application, our framework was running in the background. You could literally, on the screen, record. So you could click and record and enter numbers and record this as a script, which is wonderful. But what was even more cool is if you hit like submit or you wanted to verify that the page is right, you could right click on a control and check the text, check the button color. And I mean, I don't want to date myself, but this is like 2001. And this was really like cool stuff. Like there was no Selenium, there was no any of this stuff. We just rolled our own and this thing was awesome. We thought it was just the greatest. So we started to use it heavily. We automated everything. Like when a story came up, we'd write automated UI, acceptance tests for it, like using this framework. Testers loved it because they could just go in there and record. We recorded all these scripts. We included as in part of our build continuous integration process using cruise control at the time because I was working at ThoughtWorks and a guy named Matt Femmel had just written cruise control and that was innovative. And so we had this really cool build process and we were just rocking it. We thought, man, look at us. We're so great. And then about 3 or 4 months into the project, we noticed a couple things that were interesting. One is our build times, the amount of time it took to build and compile and jar up and release our code, went from like 10 minutes to upwards of 3 hours. And we're like, whoa, this is interesting. like we love automated tests. We want the test there to verify our stuff's working. But we also noticed that developers stopped checking in because it would take 3 hours. Like it took like, first of all, it took an hour and a half to run the suite locally to make sure that the changes you made were okay. But then it took another hour and a half on the cruise control system to verify that everything was okay there, that your stuff got merged with other people's. So it's like a 3-hour turnaround. So no surprise, developers stopped checking in. And then what kind of happened is, well, the build would break and it would stay broken for a long period of time. And this was kind of alarming because I'd be sitting with another fellow developer, we'll call him Charles. Hey Charles, we made some great changes. Should we check it in? No, it's gonna take 3 hours. Hey, I noticed the build's broken and like no one's fixing it. So we have this perpetually broken build that people are checking in on top of and like, so red flags are going off. I'm like, what's going on here? Like, why are we doing this stuff. And this is when XP was kind of popular, extreme programming. We were trying to follow these practices. And then, to make a long story short, it all came to a head where we had a really tight deadline we needed to hit. We didn't hit it, and people are like, why? Like, what happened here? Why aren't we hitting this? Why is this working this way? And it was awful. Like, people were upset, and so what was interesting was how did this tool that was so beautiful and wonderful and make our life so easy, like, we think cause us some pain later on. And so from that story, like, three things started. I mean, I didn't have it distilled at the time, but when I look back and I think about what that experience kind of taught me, was first of all that not all tests were created equal. Because the other thing that stopped happening is developers stopped writing unit tests, which I don't know if you guys know what those are. We can talk about this later. They stopped writing them because it was so easy to use this tool. Why would I write a unit test when I can just record and do this thing? Like, so not all tests were created equal. That was something that, on reflection, I kind of understood. Just because you can automate something doesn't mean that you necessarily should. With something else, I kind of learned the hard way. And then this third one, speed and feedback really, really matter. Like, I realized having that long build time and not having quick feedback about changes, like, really hurt us. So those were three takeaways that kind of just sat in the back of my mind, and I started forming opinions around. So that's the first story. Second story is much more recent. This one was about 3 years ago. Just before I joined Spotify, I was working at another energy trading company. But this one was actually swapping commodities online, and I was working there at the time as a project manager. And sorry, I didn't really introduce myself. Like, I'm an iOS developer at Spotify, but I've played lots of different roles. And in this particular company, I was a project manager for this very important physical trading company that basically swapped power. So I don't know if you know this, but you can trade physical power through brokerages online, which is why in Texas, when it gets really hot, there's actually a market for buying and selling power at Texas, because a lot of natural gas gets consumed, and you can make bets around what you think is going to happen to the price of natural gas and all this kind of stuff. And you can have, not to get into trading, that's what the system did. And so a lot of money was involved. Like this wasn't like some back-end system where it could kind of work. Like, billions, like millions and millions and millions of dollars in contracts work. So we had a lot of testers. For every one developer, we had 2 testers. It was like big QA, because a lot of emphasis was put on getting this right. We had to have this right because it was contracts and money. So that was great. We had a big, good-sized QA department, and these guys were pros. They knew the domain really well. They knew the business very well. And so that was good. But as the PM, when I was kind of looking at us executing and delivering these projects, I noticed that the devs and the QAs both were writing automated tests. But the way they did them was kind of completely different. Like, the developers had their unit tests that they wrote when they were doing Java or whatever it was they're building to build the backend functionality. And then the QA folks, they had a series of fit tests. I'm not sure if you know what those are, but basically you can think of it as they had a table of mathematical calculations that they could enter permutations of calculations into and verify they got the right numbers. And they wrote a lot of those. And they never really each maintained their own suite. Like, the developers do their thing, and the QAs did their thing. And if the developer test broke, the developers, of course, would fix their tests. If the QA test broke, QAs would, of course, fix their tests. But neither side would dream of entering the other's domain and kind of, like, there's a pretty good wall there, kind of just keeping them separate. It's not like they didn't talk or collaborate. They absolutely did. But there were different sets of suites. And I noticed when I was watching the developers, first of all, they never got concerned if the QA test broke, because those were QA tests. But also when the QA people were writing tests, I just noticed there were certain things that they could benefit from if only they knew what the developers were doing on their side when it came to writing tests. And I thought this was very interesting. And yeah.
So just saying that two different suites.
Yes.
But is there a chance to be overlapped because
Yes.
developers
Yes.
doing unit
Yes.
tests, it's business logic,
Yep.
right?
Yep. There's complete overlap. Absolutely, there was overlap. That was part of the problem. They were duplicating tests. We were running tests we didn't need to run because devs had written some unit tests that cover some cases here, but the QAs didn't quite. It's not they didn't trust. Either they didn't know, but I mean, great developers, you do your thing. But I need to be autonomous as a QA tester, and I need to have complete confidence that stuff is working from my point of view, because I objectively have to test what you're doing. Like, I'm not going to say I don't trust you, but I don't trust you. You know, kind of like that, a little bit. No, so you're absolutely right, Olga. Yeah, that was absolutely true. So what I found was that devs and QAs had this different perspective when they came to automated testing, what they thought the purpose was. I thought the testers could benefit from some things programmers instinctively did just in terms of programming practices that I wish the testers writing their automated tests knew. And I thought, boy, if only we could get these people working together. And I was never able to get it quite to the extent I wanted to before I left, but that was kind of I just realized there were a lot of inefficiencies in there that could have made it better. And it was at that time that I started thinking, boy, if only I had a book. A book that laid out some common vocabulary so that testers and developers, when they say certain words and they talk about automated testing, use the same language, like they're speaking the same language. There was some kind of framework they could go to. Shared understanding around where and when to write certain types of tests, I thought would be really good. And then sharing some common programming tips and techniques from the developers to the testers, because the testers are effectively writing code in the form of these tests. Like there's some basic things in there that would really, really help make these tests more maintainable, better, easier to, to support. And so that's kind of the genesis behind what started me wanting to collect some things and put some words onto paper. So let's just talk about words for a second. So I thought, well, what model out there kind of encapsulates what I thought captured some good practices around automated testing? And one model that I think, I don't want to say Mike Cohen came up with it because I think a lot of people were thinking about it, was the testing pyramid. Has everyone seen or understand the testing pyramid? Right. So this has been around for a while. And we all know, when you look at the pyramid, it's in the shape of a pyramid for some reasons. On the very top, we've got these user interface tests, which go end to end through the entire architecture of the application that we're testing. And they are the greatest, most definitive, confident giving test I think you can write, because they do exactly what your user's going to do. They go end to end. There's no funny business. Like, you don't miss anything. They're the most deep integration we can write. So they are wonderful from that point of view. The con of the UI test, which I found out in that first story, was that these things take a long time to run. Or they can, because sometimes you have to bring up instances of servers. They do go through multi-layers of the architecture, sometimes making network calls to databases and other places. Like, they're not a real fast test. They can take like several orders of magnitude longer than other types of tests we have. So there's a cost to these, They don't come for free. Then in the middle of that triangle of the testing pyramid, you've got these things that, this is an awful word, but our industry, and I understand what I mean when I say integration test, that's kind of what we call them. It's not a great word, because as soon as you have two things and you connect them, they're integrated. So like UI tests are a form of integration test. But what we call these things, in the context of what we're talking about here, are kind of, they don't include the UI. They include things more in the middle. And in this particular case, I'm just trying to show, it's like a web service. It would be a typical example of you sending a request to a listening endpoint, like an HTTP endpoint, and getting some JSON or some data back or something. But they're still nice because they're a form of integration test. They go through a service like this all the way down through the business logic, down to the database and all that stuff. Great for connectivity, great for making sure things are hooked up. But with integration tests, they're also not the most precise tool we have for telling us where our problem is. Like they'll tell us when something's broken, but they're not always great at telling us where. HTTP 404, like, or 500, internal server error. Like, what does that mean? Where in the plumbing did something not hook up? But they tell us, and so they're great. And at the bottom of the pyramid, we have these things called unit tests, which I think most people here probably understand and know. This is like the bread and butter thing that developers write all the time, really popularized early on with extreme programming, essential for refactoring and being able to make changes at speed with confidence. So this is the stuff, very quick, extremely focused. You can literally write unit tests for almost anything because developers can get right in there at the code level and write these things. However, that speed, the downside of all this speed and low levelness is that sometimes they will miss integrations or they'll miss bugs that only appear or manifest themselves when you actually hook things up because you're so focused on that one individual small unit of that method or whatever it is you're testing. So just for example, very quickly, a UI test, just like that user said, here is one. This happens to be written in RSpec, which is like Ruby on Rails library. Here you can see it's just basically visiting a login page, filling in some information about an email and a password, clicking the submit, the sign-in button, and then verifying that we get redirected to a page that says welcome. It's a very simple UI test that verifies login works for these credentials. Here's the integration test version of that. Now we're not going through the UI, so we're leaving that out, but now we are doing an HTTP GET to go to our login page. Then we're doing a POST, which is the mechanism a browser uses to send these credentials to the web service. In this case, it's going to be our email, username, and password. And then it follows a redirect to verify again that we got into a page that has an HTML H1 header with the word welcome. Very similar test, just not going through the UI, now one layer down. And an example of a unit test now. Here's where we could create a user in the business domain. We could write tests that under certain conditions a user should be valid or invalid if we make their name blank. But the beauty of these is if we can do a lot of different combinations of things here. We can test that all the fields are required, what happens if the email is not unique, if we want to check that there's a certain limit on the number of characters we allow or a certain minimum number. We can write unit tests and test all those things. There's some language. There's the pyramid. Now the neat question is, well, which test is right for that login page? What's the right test? It depends. It depends. Yes, absolutely. Because your perspective is going to change what you think is the right test in this context, in your role, what you're doing. It really does depend. Because we have 3 ways of testing a login page now. Like we have 3 different types of approaches we could take. And this is the thing I found so interesting. Mostly participating as a developer on projects, but also working a ton with testers in QA and having a passion for testing, I found that people's perspective, sometimes each side doesn't fully understand what the other one's looking for. So like what developers are looking for as a developer, it's about speed and feedback. They want really quick feedback about whether the code they've written works and whether or not it's safe to make changes, check in, so they can refactor and aggressively change and improve the design of their code at speed. So from a developer point of view, there's the need for speed. They love speed, which is why they love their unit tests. But if I'm a tester, and there's some history that we've had for half a century around the role of testing and as a QA group being responsible for the quality of a project or of a product coming out. If that's kind of been historically, I know now with Agile, quality is a team responsibility and all this kind of stuff, which is great, but a lot of testers or people I've worked with still have a little bit of this mentality that, well, if sticks are going to come up and I'm going to get beat up for not testing everything, I'm going to go for completeness. In other words, I'm not so concerned about speed here. I want to test every permutation and combination because that's how I think. That's how I work when I create my test plan. That's what makes me effective. I'm literally like a detective going in with a flashlight. I'm trying to break this in all these different ways. And if I can automate some of that so that my releases come out I have to do less of that manually every time. That's great for me. That's what I want to do. So I'm going to have a different view of the purposes of these tests and which test would be right in this case. And that took me like 20 years to understand and appreciate. Like I didn't appreciate that because it's not very often that we kind of crisscross in a different world and we get to experience and see what things are like. So, but I found that very interesting, these trade-offs. And of course, this manifests itself in just when you're a team coming together and you've got testers and developers and you're thinking about philosophies, this manifests itself in different ways. These are things that devs are going to find very important. And these are some things that QA are going to find very important. And sometimes those will conflict because they are looking at the purpose of automated testing through a different lens. One's going to be about speed, one's going to be about completeness, one's not concerned about speed, the other one's not concerned about completeness. And it's just so, if you think that you're going to bring automated testing to a team and sometimes not have these things in the back of your mind, I think this is why a lot of automated testing initiatives struggle. It's because they get the duplication, they get the overlap. It's that the people aren't necessarily chatting with one another because they have these different views on things. And so then you've got this murky role of what happens in between these two. Because this is the strange thing that's happened with, I think, QA and testing over the last 15 years with the rise of agile and testing becoming more of a team responsibility and developers being looked at to write tests, and that is, well, I might be over here like a really strong traditional tester who knows the domain very well, who's starting to get into automation, but I don't know what these things called unit tests are. I'm thinking I have to test everything, and the UI test is my hammer. Like that's a beautiful mechanism. That gives me the most confidence that this thing is actually working. So I'm going to want to have lots of those to cover my bases and make sure this product goes out well from a completeness point of view. And of course, the developer's like, well, I've already covered a lot of those cases with unit tests. Do we even need these things called UI tests? Like, why are you guys so excited about that? That slows us down. I can't iterate. I don't want to wait for the UI test to run. I want to check in quickly. And then you get into these scenarios where developers want to check in the UI tests, haven't finished running, and then they break. And it's like, well, who fixes them now? It's like, it can just lead to a whole bunch of dysfunction and waste on a team, basically, if you're not kind of in sync on these things. So there's kind of this like middle ground, which is kind of strange. Like, well, who's rating what tests? And so it can lead to all sorts of interesting confusion. So what I like bringing to teams, or at least engaging to teams to see, is to see if they have this model, or at least they've talked about it, they understand what these words and terms mean, and that they understand the implications of why this is a pyramid. So I like QA folks to understand that, and I like developers who maybe aren't into automated testing to understand that we're expecting them to write a lot of unit tests in their code. Like that's the fastest form of feedback we got. Developers kind of have to write these things. You can't offload that to someone else, devs. You have to write these things. It's in the code. You have to be a programmer. They're at that level. You're our first line of defense in making sure that we've got some robustness there. So we like to cover and start and cover as many bases as we can here. Then we can climb and step up as necessary and add more integration tests. Some teams stop there. And then some teams will go up and think, okay, let's think really strategically, what UI test do we want to run? Because these things are expensive. We don't want to blanket everything with them. We just want to be a little bit more choosy about where and how we use those. So I like talking about these rules of thumb and just having the team discuss and have a conversation. And it doesn't always have to be exactly this way, and we'll get into that in a little bit later. But it's just at least a conversation starter. It's a framework, it's some language, and I find it very useful just to put in front of teams to make sure, because some teams aren't even aware of this, depending upon where they're coming from, what their histories are. It's just not even something they talk about, basically. Okay, so let's just quickly talk about programming. So when I was working with these testers on this last project a couple of years ago, I realized like there's some really simple things that testers, when they're writing their automated tests, could be doing to help make them easier to maintain, easier to read. And so I wanted to try to collect some things that may seem really obvious to everyone, but may not seem so obvious to people who don't write code a lot, or are just kind of getting into it for the first time. So the first thing I just wanted to highlight is the importance of names. Like, developers spend a lot of time thinking about the names of things in their programs, the names of their variables, the names of their methods, and there's a really good reason why. So can anyone tell me what this little snippet of code does? If val b redirect logum pug, else redirect login pug end. Like, I have no idea. I have no idea what that means. Like, what if we chose some names? Yeah, like what if we, gave it, like, instead of calling that b, call it password, and what if calling that welcome pug, like, actually spell out the word welcome page? Like of course this is an exaggerated example, but we've all, I've certainly felt it. I've come back to code I've written sometimes and I go, what did I mean when I wrote that? Like, and there's this history, like a long time ago, we couldn't always have super long names. We had to be a little bit more memory conscious and things like that. But those days are largely gone for most of the systems we build today. So we can give these things good names. And we're writing tests. You can give your tests and the things happening in your tests good names. So that not just you, but the people following you and the other people coming and maintaining it can understand what your intent was. So names are very, very important. And so we try to pick names that are easy to understand, like salary instead of S. We try to make the intent clear. Like, we could just call it red, or we could call it the brand color. Something that explains. We try to get away from these things called magic numbers. Like 60, maybe people know that means 60 minutes or 60 seconds, or it could be seconds per minute, like, Something not too long, because there is a trade-off between going super long and having something that does fit on the width of the screen that we can see at a glance. Descriptive, and some of these are more subtle. We try to avoid what are called double negatives, like is not valid. That always hurts my head. Like, what? Like, is not valid.
I once worked on some software written by a hardware engineer.
Oh, man.
The first line of code said, not disabled flag.
They think in binary, like those guys.
They
like,
think in negative logic.
yeah,
Right?
yeah.
Oh my God.
Yeah, that's a whole different breed.
Yeah.
Like, yeah, no, totally. So those are just some examples. Like, names are very, very important. So when we're writing automated tests, as testers get into this, like, the names matter. Like, we should think and not rush this and try to think of good names for the things. And ultimately, hopefully these things line up with our business also. So the terms we use, we like to have matching our tests with what we use to describe the business. All right, here's a very quick video. I don't know if you guys have seen this, but let's just talk about something called spacing.
Oh, I kind of understand where you're going with this, and
Okay.
completely agree. Richard, what's wrong?
Nothing. Literally, it's all good. Come on.
Oh my God,
Sorry.
your roommates are right. You really hate spaces.
No. I don't. It's not hate. Hate's a strong word. Truth be told, I do have a slight preference for tabs, but that's only because I'm anal and because I prefer precision.
Well, not to pick a fight here, but if you really care about precision, wouldn't you use spaces? But whatever. Once it goes through the compiler, it's the same thing, right?
Yeah, technically, yes. I just don't understand why anyone would use spaces over tabs. Like, if it's all the same, well, why not just use tabs?
Because it could look different on other people's computers.
Tabs create smaller file sizes. All right, I run a conceptual company, and I've devoted my life to minimalizing file sizes. It's what I do. I mean, I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us. You know what? I don't think this is gonna work. I'm so sorry. I mean, like, what? We're gonna bring kids into this world without over the heads? That's not really fair to them, don't you think?
So, anyways, that's this is important stuff to developers. Like, just so you know, if you want to start a fight at a cocktail party, just bring up spaces versus tabs or editors. And this was on a sitcom on HBO called Silicon Valley. If you're interested, it's quite funny. We don't need to, I think, stress here about spaces versus tabs. We don't need to get into that. But there's something subtle that they're talking about here, and just something as simple as indentation can make a big difference when you're writing code. And now this all may seem kind of like, of course, like this is so obvious, but like writing tests, which is like, I'm sorry, I should back up. I'm making an assumption here when I say automated testing. And I should have said this in the beginning. When I talk about automated testing, I'm talking about automated testing where you're writing code to automate the tests. I'm not talking about record playback scripts where it's just magically taken care of. Like, we can talk about, yeah, sorry, go ahead. We can like talk about those later, but I'm talking like about code basically and making that assumption. So when you're writing code and tests, like it's almost like you're writing like a story. Like you want it to be really clear. It's almost like prose, like you're an author writing these things. So you want to have good names, you want it to be well spaced, and indentation really helps just understand the flow and avoid bugs that can sometimes happen just because you're not seeing things. And depending upon what editor you're using and things happen, they can take care of that for you. But indenting can make a big difference, along with just simple white spacing. So when you're writing your test, something as simple as just putting a little bit of a space here, kind of trying to show the flow and the chunks of work and even the occasional comment. I think comments are fine, just to kind of clarify your thinking when you come back, look at it at a glance. All these little things really add up and make your tests more readable and maintainable. And then the third one here is duplication, which is a blessing in disguise, because this is something that I noticed that the testers I was working with really liked. And what they would do is they would have a test that say tests role-based security and authorization access to a given page. So under these roles, you can access this page, and under these roles you can't. We can write an automated test that does that for this particular page. A couple weeks later, another story comes up, new page. We need security in that page. What are we going to do? Well, it's just like the other page. So I'm just going to copy and paste what we did on that page for this new secret page. And I'll tweak the test, of course, because the administrator has access to this one, but they didn't on the other. But I'm done. Like, that was great. Like, look how fast, look how great it is. Now we've got a test backing us up. And then, of course, we can do it again. That's one obvious way, like something that we really try to do, which we should be doing in our tests as well as production code, is like removing that duplication as much as we can, so that when we need to go back and change whether the administrator can access that code, we can do it in one place instead of three. Like, that's a real obvious one that most people get. A more subtle one that I found the team I was working with struggling with a bit was, imagine you have a series of financial calculations you need to make, and there's some equations you want to test. Take an interest rate calculation. To calculate the interest on a mortgage, I need, the tax rate, the amortization period, blah, 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 blah. We could write a series of tests that maybe require 3 lines to test this functionality, and then we're done. What I noticed sometimes people would do is, as more tests and permutations came up, they would just extend that data and add more lines of data to work with, write more tests against it, and that would kind of grow over time until you had a fit file or an Excel file with 2,000 lines in it containing data and calculations, testing really your entire business logic of that unit. Now, can anyone see the challenge with that?
I mean, other than when things change?
Exactly. What happens if one test breaks? What line of data in that Excel file caused that test to break? They had no idea. No idea.
Also, the time should also grow instead of increasing it.
Yeah. No, it wasn't it wasn't the tester's fault. They were just, look, I've got an Excel spreadsheet with some data, super handy. The data is set up in a certain way that I understand, because I've been working with it so long. I'm just going to write more tests against that data. Naturally, I would. There's deadlines. I've got to test this. I've got to get it out. I'm just going to add, oh, the data doesn't handle this case. I'll add a little more data, and then I'll write another test over here to test that data. And that, over years, that grows. What's missing there is the power that sometimes, this is what developers will do, they'll write an isolated test where they will pull out those 3 lines, write some very specific test with those 5 lines, and then they have a coupling, a very direct coupling between the data and what they want to test with it. That's a powerful mechanism that I found doesn't come naturally to people when they just get into coding. Like, they're just not aware of that. They're used to working with the 5,000 lines of Excel, and they just know it kind of works, and they just don't jiggle it too much, and it, but when things break, hundreds of hours are lost because someone, an expert, has to go in there, look at all that data and parse it and find the one offending line that's causing the data to misbehave or do whatever. So that's the more subtle example of duplication that if only I had the developers pairing with the QAs and they were interested in this, we could have solved that. And in fact, that's what we did in the latter part of the time when I was there. We took these 2,000 line files and I kind of asked the team to deconstruct them. Like, I wanted to get rid of them all because we were spending hundreds of hours on stuff that was just, but they were valuable and it's a financial, and so we had to be a little strategic about it. But that's kind of what I was fighting when we left, was trying to get rid of that. Okay, a few pitfalls just to look out for, I find, when teams first get in. One, has everyone seen this inverted cone? Right, so this is when you start. You've got lots of UI tests at the very top and few, if any, kind of unit tests at the bottom. This is sometimes called an anti-pattern, just because the pyramid is shaped like a pyramid for a reason. These things are really expensive, these things are cheap, so we want them to look like this. It's not necessarily the end of the world, because sometimes when teams start, like depending upon who in the team wants to automate and to what extent they can, sometimes you'll end up with this. We had this in the early days of Spotify. When we were building our early client iOS application, our iOS developers, Apple didn't have a culture of automated testing early on. I don't know if any people know this. It was terrible. It was like 10 years behind the rest of the industry. It was like going back to the Stone Ages. Like, they just didn't have anything. They didn't even have a unit testing framework to write unit tests. So as an Apple engineer or an iOS engineer, you would make it look good. You'd build a great GUI and all that, but automated testing isn't something that in the early days of Xcode and iOS development was really promoted. Like, Apple itself was kind of clueless. Like, they were kind of brought into the modern century. We'll talk about other stuff like that later. So we started off with this at Spotify, in fact, because we knew the value of automating the tests. We couldn't ship a product to millions of people and not have some form of automation that verified you could log in and do things. So we started off automating a lot here. Of course, no surprise, those builds got really long, the tests got really long, it was getting harder and harder to release. So it took us, I mean, we're still doing it. We're much better now. I'd say it's more like that maybe, but it's taken years to kind of unravel that, but we are, and we're aware of that trade-off, but that's how we started. So it's not the worst place in the world to be. I think it's just good to know where you want to go.
And why you're there.
Yeah, and why you're there also.
Because
Yeah.
what you're doing is mostly UI logic.
Yeah.
As opposed to complex,
Yeah.
business logic.
Yeah.
And why would you have a lot of unit
Right. Yeah, because the beauty of these things, they do go end to end, and maybe it's good enough for our project to ship right now. Maybe that's all we need. Like, it's always contextual too. Like, it's just, it really depends.
Why?
Yeah. Flaky tests. Does everyone know what a flaky test is? Everyone experienced the flaky test? No? So one of these neat things about these automated tests is one of the great purposes of these tests is they tell you when you've made a change to the system and it's safe, because all your tests run and all of the expectations you had before worked. In other words, the money will flow, the interest rates will calculate correctly. Like, we can write tests to prove that works. Now imagine, say 5 times out of 100, you make a change and a test breaks, but you don't think it should break. You run it again, now it passes. You run it again, pass, but then it fails. Run again, pass, it works. But you haven't changed any code. That's a flaky test. One that sometimes passes, sometimes doesn't, but you haven't changed anything. But for many different reasons, it doesn't give you the confidence, well, did I break anything? Is it safe to release into production? You don't know. It's a flaky test. So that's what we mean. The build is broken. They waste a lot of time. We fight this hard at Spotify because flaky tests just slow everything down. We don't know whether it's safe to do a release. We don't know it's safe to submit our latest app to Apple. We don't know whether it's safe to release to Android or the keyboard and mouse. Like, so the definition of a flaky test is anything that doesn't run reliably.
But what kind of test is that?
Yeah. So for example,
Test.
I typically not unless it's a unit test that is making a distributed network call to a database that maybe is an integration test, which maybe isn't running. So when the database is up, no problem, but once in a while it's down. That would be an example. More often it's in that integration layer. It's more like we need a test instance of LDAP running, because that's where we get our user credentials from. And then we need something to fake out the Sony licensing engine to verify that we can get our licenses from there. Of course, we don't have a production version of that, so we have something running, but there's a lot of infrastructure that sometimes goes into making these things. And if any of those aren't set up perfectly, they can cause the test to fail. It's flaky. Sometimes it's a race condition. Sometimes we have a pool of users configured that we can pull in different configurations. Here's a premium user, here's a free one. We went to the pool and there were none left. It failed. We haven't changed any code. It's just a resource we needed wasn't there. So, flaky test. Like, it manifests itself in lots of different ways, but it's anything that we just can't run reliably over and over and over again, because it makes us pause and scratch our head and go, So, I mean, in terms of if you start running into these, there's a couple things we can do. You can rewrite the test. That's great. Like, take that flaky test and just revisit it. Is there a way we can test the thing we want to verify works in not such a flaky way? Okay, that's an obvious one to try. Another one is sometimes if you're really up high in the pyramid and you require a lot of moving machinery to make that thing work, maybe it's something that can be pushed down further. So maybe we can cover it in unit test and we don't need all these different pieces. And the third option is sometimes just to kill it, because you can spend a lot of time chasing flaky tests and trying to get them to work perfectly. And that's what Facebook does, which is interesting. When they get a flaky test in their system, they don't even try to fix it. They just automatically kill it. Like, no human intervention involved. You're flaky, you haven't been running reliably, boom, you're gone. And then it's your responsibility as the team or the developer to just write a better test next time. Like, we're not even going to waste hours trying to figure out why it failed, just write a better test.
So you still are back to number one then?
Yeah,
Because
yeah,
you've
yeah,
now
yeah.
you're not covering something.
Or not, or, yeah.
Well, but you're not covering something you thought you needed to cover.
Yeah,
So
yes.
then you have to decide.
Yeah, and it's a trade-off, right?
Yeah.
Like, I would really like to have a test that, verifies that the leap year 29th shows up in my calendar in JavaScript, but it's a hard test to set up. So I'm going to manually test it this once. It's code that we don't touch too often. If you want to write in your test plan and manually test it, we can, but I'm not going to worry about it. Like, it's a risk I'm prepared to take. I'm taking the risk. I'm just not going to automate that. Like, it's a choice. Like,
So they must do enough analysis to know that it's okay to kill. I mean, because you could put up number 4 there, which is comment it out and figure it out later, right?
yeah,
Which
yeah,
is another behavior that you see.
yeah.
I think they
Right.
have kind of more complicated.
Oh, yeah.
If test fails, they put it in kind of in quarantine.
Mhm.
Then
Yeah.
they run it separately. If it passes finally, it goes up and goes back to developers. Developers don't have to look at it like every time. Like,
Mm.
like if quarantine like last week, you have to look at it.
Mm.
Just
Mhm.
some
Yeah.
kind of system. It's not
Yeah, maybe it's
immediately they
maybe
don't-
it's not completely automatic. I just have a link in the book that talks to where I heard. So Kent Beck is a guy who wrote early versions of XP, and that he works at Facebook, and that was kind of just what he said in a blog post he wrote. Like, when we get a flaky test, we just kill it. Maybe behind the scenes they don't quite kill it the way he said, but that was the attitude he was saying.
Our presentation
Yeah.
Digitac, and it was like 1 hour presentation.
Oh, okay.
Facebook,
Yeah.
explain all this stuff. And, yeah, it's kind of complicated.
Yeah. So maybe they don't outright kill it, but I think the attitude's an interesting one, which is
But
don't
eventually
spend
they
10
kill
hours a
Yeah,
day on it. Get it out of the way. Like, do not let it slow you down in releasing and doing what you ultimately need to do. Yeah. But yeah, flaky tests, those can be painful. And then the last one here is just basically not working together, like having this wall and you've got your tests, you've got your tests, and you know, I don't want to spend time with you, you probably don't want to spend time with me, and you know, of course it's better if we work together. So, so this is where I kind of, what I wanted to do when I got here was, like originally when I was putting this presentation together and I was trying to imagine who I'd be speaking to in the audience, I was imagining there are testers who either want to get into automation, aren't sure how, or they're starting to poke and get into it a little bit, but if I really want to, like I see a huge opportunity for QA engineers and people who want to get into test automation. I just see companies screaming for it everywhere. Like we're looking for it at Spotify. I see a lot of companies probably in the Valley here are looking for it. Like it's a really big, popular, I think valuable skill set if people want to get into that. So I was trying to think of tips on how to start around this stuff. And I think one thing that, I mean, you don't have to do this, of course, but one thing I think that would really help, in particular with the web, if you find you're doing a lot of web testing, is that I encourage testers just to go kind of build some kind of website, like on your own, something very basic, very simple. Maybe you don't, I'm not so concerned about you knowing SQL, but understanding how some of these core technologies work a little bit really, really helps when it comes to using these frameworks and understanding why they ask you to do the things they do. So for example, in the book, I have an entire chapter explaining how to select elements on a web page through CSS. Because that's what these web frameworks do. They have to find a way of IDing a control on a web page, often through something called an ID. And if you understand that HTML uses tags, CSS is a language or a scripting language that lets you grab elements on a page, you kind of get it then. It doesn't matter whether you're using WebDriver, Selenium, some tool from HP, or something from .NET. Once you understand the fundamentals of, a few fundamentals of what these technologies do and what these frameworks have to do, you can use any framework, which is, in the book, something I very consciously did. Like one question I get for a lot of people when they look at the book is, what testing tool did you use? I go, it's not about the testing tools. Like, I really don't care about the testing tools. I don't want you to even think about the testing tools. If you really want to know, I picked RSpec from Rails because it's the most human readable language you can understand for automated testing. And I think Rails really leads in this space. But it's more the concepts of understanding how elements get selected. When you write an integration test and you query a web server, there's 4 verbs: get, post, update, delete. And with those, you can do anything. You can drive any website in the world once you understand 4 simple verbs of HTTP. So we talk about that. Like how when you go into a browser and you type in www.google.com, that's a get to a web page. And it gets the HTML and it puts it in your browser. Like once you understand a few simple things like that, everything's a lot more clear. So that's kind of what I try to emphasize. And that's why I encourage testers just to go make a web page that says, hello, my name's Billy, and style it up a bit, like give it a header. And then you don't have to get into JavaScript if you want, although I do cover that in the book also. But then just write a test that makes it do something. Like see if you can grab your name and verify that Billy's on the page. Once you get that, like just everything becomes a lot easier, I think. So that's, I try to emphasize that. The other tip I have for testers, these are my sons, is I try to get them to befriend a developer. Because developers really hold a lot of these keys. Like it's hard if you're a tester and you're not into the technology, you don't know how to set these things up. Like setting a test framework up and having something to get going on. Like once you have the example, it's not rocket science. Like I think anyone can write good automated tests, but sometimes just having someone get you going a bit can really, really help. So I really encourage testers to try to befriend a local developer and just, hey, I can make your life a lot easier because I know you're really busy and you'd rather be working on whiz-bang new features. Let me help you by, if you can just help me get going here. Like, it's a nice way, if you're a tester who wants to get into that space, that's one way to get in there, is kind of befriend a developer and say, look, this is how I can help you. I'm going to help you look like a rock star. Your stuff's going to be bug-free. I'm going to tell you like all the problems it's going to find, and I'm going to help automate it so we can both look really good here. Like, so I think befriending is, and I also encourage developers to befriend a tester because they can totally, huge value in having someone critically look at what you've done and give that perspective. So I encourage the other way too. And of course you should read that book. This has been 2 years of me trying to think about how to, and of course you never get everything in there you like, and it could have been 1,000 pages, but I really try to just make it a simple beginner's guide so that if you want to understand how some of these core technologies, I just picked the web because it's a universal platform that I think a lot of us use. How the web works, how automated testing works, how these frameworks work, and a few basics around programming. I think my hope is that that'll make and empower more testers to kind of get into this space and not be afraid to get in there, because it can be it's a step up sometimes. There's a step there. And I didn't find anything else that helped. So this is the book, when I was at my last client before Spotify, this is the book I wanted to give the testers. I said, just skim through this and just look at a few things here and then let's talk. It was kind of like what I wanted to have. Like, that's the book I wish I had, and I didn't at the time. So yeah, so it's there. This week only, it is 20% off if you go to the Prags and you type in California, or you can buy it off Amazon if you want. We're going to raffle one off here, but yeah, that's kind of how I came here. And the other thing, of course, I encourage, because developers have to do this, and I encourage testers, is just start by writing lots of automated tests. Like, don't worry about, is this the right test? Is this the perfect test? Like, you just have to write a lot of bad tests before you realize which ones are adding value. Occasionally, a few good ones will come out, and you go, that was good, that was good. And then you'll see which ones are just kind of not maybe as good as these other ones. It's just experience. Like, you just got to go out there and you got to shoot a lot of pucks or hit a lot of golf balls, whatever. I think that's just the best way to start. And then you'll get better naturally. And that's it. So hopefully we can have some good discussion. Thank you.